right? If y is 0, that's an x-intercept. Okay, we know that if that's the case, then x minus that number, in this case, is one of our factors. Okay, so x minus 1 and x minus 3 would both be factors. The other thing they wanted us to pick up, and this is from Unit 3, okay, so far we only have a polynomial degree 2, right? Okay, so far we only have polynomial degree 2 because we have x times x would just give us x squared. But from Unit 3, we learned that if we have a local maximum, what that means is that it's higher than all the other points. They also told us that it's a x-intercept, or excuse me, that we know it's an x-intercept because it's on the x-axis. So it tells me it looks like this. What did we know about the multiplicity of zeros when they just touch the graph and go back? We know that they have an even multiplicity, so we know this has to happen at least twice. Okay? So this gives me a function that has 1, 0 as one of the intercepts. 3, 0 will be a local maximum because it will touch the graph at 3 and go back down. Okay? Will this be degree 3? It will, because I'll multiply x and 2 x's there. It would look like this. X minus 1, x minus 3 squared means x minus 3 and x minus 3. Okay, that would be an example. Now, they didn't tell me what they wanted my end behavior to do. If they did, I would know whether to make the front positive or negative. Okay, but in this case, all they've requested is this information, so that will work. Okay, there are others that will work. You can multiply by a number in front, as long as you didn't multiply by another x. You would be absolutely okay on that problem. Okay, so you just take the information they gave you and you go from there. Alright, so hopefully that gives you a little bit of help as you're setting these equations up. Let me know if you have questions.